Rahman Rahim. Today we are starting chapter 5 that is related to equations, inequalities and graph. This is a very important topic for O-level and IGCSE level students, and in this section we will study some graphical and algebraic equations such as ax plus b and modulus, and similarly equals to cx plus d in modulus. So we will discuss this absolute value or modulus value, which will always be positive. If it gets negative, this value within this modulus is negative, it becomes positive due to this modulus values. So this is a little bit tricky initially, but once we have proper understanding, then it becomes a second nature. So it's very easy. And in the next we will see some this line equation ax plus b, which is greater than, equals to, or less than, or equals to, or similarly we'll compare two equations in a modulus form. So this is also very important. So let's start this chapter, and then some cubic equations, inequalities, less than and greater than condition. Here we have a polynomial of order 3. So this is cubic inequalities, and similarly other substitution methods, and finally the exam questions. Now start exercise 5.1, and this is question number 1. 2x minus 1 modulus is equals to modulus x. This is question number 1, part A. So solve this. This is question number 1, part A. So this is 2x minus 1. This is a modulus value. Here we have also modulus value. So 2x minus 1 is equals to x. If we open this, it becomes plus minus. So this is plus, this is minus. Now solve this. 2x minus 1 is equal to x. So if we open this, this becomes, because we never know the internal value is positive or negative. So if it is a positive, and then for this negative, so if we change the sign with a bracket, we can write minus. So we can solve, say, and once we obtain this equation and this equation, so as a result of this modulus, we have these two equations, and you will see it in a graph. And from this we have this x shifted here and 1 into here, and this is x minus 1 is equal to 0, x is equal to 1. So this is one of the solution, and from this 2x minus 1 is equal to minus x. So this x is shifted here, 1 is there, and x is equal to 1 over 3. So we have these two solutions, and let's plot this equation. 2x minus 1 this is basically 2x minus 1. This blue graph is 2x minus 1. When we substitute y is equal to 0, then 2x minus 1 if we substitute this equals to 0, this is y value as a function of x, that is y. So then value of y becomes, if y is equal to 0, then x is equal to 0.5. So at 0.5, if we substitute value of 0.5, then this 0.5 is multiplied with this becomes 0. So at 0.5 we have this 0 value, and similarly so if we substitute x is equal to 0, then y becomes minus 1. So y becomes minus 1. So when we substitute x is equal to 0, then this y becomes minus 1. Here, this graph will extend and will appear here, but we have taken a modulus value, so this graph will shift over here because of this modulus value, otherwise the slope of this graph is this. Similarly for x value, x is 1, y is 1. For x is equal to 2, y is 2. So we are plotting this is x, but on the other side this is the mirror image of this x. This is because of modulus. So in place of minus 1, it becomes minus 1, but this minus 1 will shift to here. So this is positive 1. So, and we can see that this red line, that is x modulus, and this blue curve, this is 2x minus 1 modulus. And we can see that it is intersecting at these two locations, which is 1 and 1 upon 3. I think. So this is 1 and 1 upon 3 is one of the solution. So we can see from here. This is very simple. I have drawn it this one, and this modulus value, we can easily draw this 2x minus 1, which is here, and afterward we see the reflection. So we substitute the negative value, it becomes positive, and then we plot this. Similarly for this one, y is equal to x, and this is the reflection on a negative side because this is 0. So this is part 1, question number 1. Now second part B, x plus 5 modulus is equal to x minus 4 modulus. So x plus 5 is equal to x minus 4 in a positive sense. When this is negative, then x plus 5 is equal to minus x minus 4. And on solving this, we have this is no solution, because this x will cancel with this one on both sides. So 5 is equals to minus 4, which is a false condition. So this is not true. And from the other side, x minus 5 is equal to minus bracket x minus 4. And on simplification, we have obtained x is equal to minus half. So this is x minus half. So we'll plot this x plus 5 and x minus 4 on the graph. This is x plus 5. This is x plus 5. When we substitute x is equal to 0, then its value will be 5. When x is equal to 0 here, when x is equal to 0, the value of y is equal to 5. So because this is x plus 5, this graph, this slope is x plus 5, and this part is just a mirror image. We can draw this one line here, projection, and we can see the mirror image. Similarly, this is x minus 4, this is x minus 4. At x is equal to 4, y is 0, so this is the point. At x is equal to 10, y is equal to 6. This is 6. So we just draw this, and this is the mirror image because of this modulus. So this is the normal value, normal line, and on this is the reflection. So we can see that this red line and blue line is parallel on the y negative axis, negative side, and on the positive quadrant 1, this is going to parallel. So there is only one intersection, and we have seen this in the problem that we have only one solution. Here in part B. So this is the concept of this problem. So this is the why we have this answer and this is not. Why we have these two answers here, x half and 1. So this is the reason which is plotted through and shown here. So graphically we can see there are two solutions because there are two intersections. Red line and blue lines are cutting at two places, crossing at two places, here at only one place. Well, on the other side it is parallel, and on the other side this is parallel. So this is question 5. And now problem 5.1, question 1, A, B. And now we are going to see the question part C. Similarly, part C we have solved similarly. 2x minus 3, 4 minus x for positive. For negative we have this negative 2x minus 3, and then this is negative. So on solving, this is minus 1, this is 7 by 3 on simplification of this part and this section, and we draw this 2x minus 3 and 4 minus x on the graph. This is question number C. 2x minus 3 is this graph, and this is the reflection, and similarly this 4 minus x, this is basically 4 minus x is this graph, and this is the reflection. This is 4 minus x. So at intersecting at 2 points at 2 places, this one and this one. So we have these two solutions. Similarly, part D, E, we can solve it. F, so the solutions are here. Now question G, we have this 3x minus 2, 2x plus 5. So this is 3x minus 2 is equal to 2x plus 5. 3x minus 2 is equal to minus 2x plus 5. So once we write in a positive, and the second we write with negative, and then we solve it. We have x is equal to 7 and x is equal to minus 3 upon 5. So we plot this, and we plot this line with modulus value. So this is part G, and this is 3x minus 2, and this is the mirror image of this line. We just draw a normal here at this point, and we can, so it intersects the red line at this point and here again. So this there are two solutions. Similarly, for part E, I, 2 minus x is equal to 5 modulus half x plus 1. So this is 2x, this is positive. For negative, we can write this 2 minus x minus 5r. So on simplification, we have obtained minus 6 upon 7, and for this we have minus 14 upon 3. So we plot it on the graph. See, so this is one of the graph, and this is 2x minus x. This is the reflection with the normal value. Similarly for this, so this is just reflection, and it intersecting at 2 points at this location, at this location. So here we have two solutions. So this is question number 1. So this graphical interpretation is just to make sure that how many solutions we have obtained, but this graphical representation at this stage was not required, but I draw it just to give a proper concept, so the student can understand why we are getting two answers or one answer. So this is also plotted here in a question 2. We have x minus 5, y is equal to x minus 8. Now we're solving this simultaneously, and this x minus 5 equal to this, and we can now split this into two parts. So x minus 5 is equal to 8 minus x in a positive one, x minus 5 is equal to minus 8 minus x. So we actually done the same in the part 1 in question number 1. Now we are doing it in question number 2 the same. So from this we have this x minus 5 is equal to 8 minus x, 2x is equal to 13 by 2 from equation 2. From the negative portion we have this x equal to this, so this is false. So now we will substitute this x 13 upon 2 and we'll get the value of y is equal to 3 upon 2. So we have this solution 13 upon 2 and y is equal to 3 upon 2. So this is we have to draw this graphically, since y is always positive, because we take this as a y value. So this is also very positive. So because of modulus value, so this point A is basically the intersecting point where x is equal to, here we have x is equal to 13 upon 2, which is 6.5, and y is equal to 3 upon 2, which is 1.5. And this is represented here. This is 6.5 and this is 1.5. This is the graph for this x minus 5. This is the graph of x minus 5. This is 8 minus x modulus. So this is question number 2. Similarly, this question number 3, we have this 6x plus 2 square plus 7 modulus x plus 2 minus 3 is equal to 0. So we take this on this side and the rest is two terms on the other side. So this 6x plus 2 square, one for positive side, this is positive 3 minus 7x, and one for the negative. With the negative sign on this side, this becomes positive and this becomes negative. So this we have obtained this. Now we have this equation 1, and for equation 2, on opening this side. So whenever whether it's open negative or positive, this square always gives us a positive value. So we have these two equations. Now we have this equation 1 and equation 2. From equation 1 we have this. So from this equation 1 we have this value 6x plus 2 square is equal to 3 minus 7x plus 2. So we have to split this with in this equation into two parts. For we shift it this on the other side, and non-modulus values on the one side, and the modulus is on the left hand side. So this is 7x plus 2 modulus. So we just rearrange it and we have this value. Now after rearranging, we take this one for the positive and other for the negative. So just split this into two parts. So this is the first part and this is the second. So we solve it, this section, and then this part. One for the positive modulus and one for the negative modulus. So this is very important question. This is question number 3 is very important from examination point of view. So this from this equation can be split into two parts, and this part A and part B side, and we have obtained by simplifications, to make it easy, we take some tricks like y is equal to x plus 2. Whether we can solve it in any way, but eventually we will obtain some results. So this is this value, and since we have assumed this y is equal to x plus 2, so we place this y is equal to x plus 2 and we will obtain this. So we have these two solutions from this side, similarly for this we have these two solutions. This is question from equation 1. By using equation 1 we have a dot here, and similarly the case 2 for this equation 2. On next page we have this equation number 2, and we did the same activity with that equation. So and from that we have obtained this and we check this all the solutions. Checking, we draw this. This is 3 minus 7 modulus x plus 2. This is the graph that we have plotted. So this is basically the slope without modulus value, and because this is a mirror image, so we have, with this normal we have this mirror image. Similarly for x plus 2 minus 3 we have this term, and at this value we draw this. Because the x is equal to minus 2, this is minus 3, because this modulus value will be 0 at minus 2, and then this value will be minus 3 at that time. Similarly for this 3 minus x 7x plus 2, this. So this curve on the other side, basically we have this modulus and this modulus, and this is square terms. So we have one square term. Basically this is, it will always gives a positive result, and we have plotted this, basically this one and this one. So as a result of this we have this. So we can see that where this square, this 6x square is intersecting this modulus values. So there we have this point here, this modulus value is intersecting it, and here we, so with the 4 solution at this point, this point, this point and this point, we have only 2 true solutions which intersect the modulus or which satisfied it. So this point is basically the solution. So we have obtained 4 solutions, and we checked everyone. So from this we have minus 7 upon 2. From this we have x equal to minus half. So 1 solution, 2 solution, and similarly minus 5 upon 3 and minus 7 upon 3. So we have 4 solutions obtained, and we checked. So first one minus 7 upon 2, and we see that this is not satisfying. So minus 7 upon 2 is not satisfying. Similarly minus 5 upon 3, so it is satisfying. X is equal to minus half, you see that's not satisfying. And the last one, x equal to minus 7 upon 3 is satisfying. Left hand side, right hand side is satisfying this equation, given equation. On placing the values we have this. So our solution is minus 5 upon 3 and minus 7 upon 3, and it is represented in this diagram. This is minus this is minus 1.7 or something. So we can see this. So we have these two solutions. So this 5 upon 3 minus 5 upon 3 which is minus 1.66 minus 1.66 and so this point is minus 1.66 and this is 2.3 or so. Let's see, 7 upon 3. So this is 2.33. So this is 2.33 minus 2.33. So these two solutions, this one and this intersecting point. So this is question number 3. Now question number 4 can be solved in a similar way, and we have drawn this. And from this question we see that we have intersection at 4 points. So from this, I'm not explaining it but just showing it that here this same modulus line, so this is the reflection, and this on the other side we have this term x square plus 8. This blue line is basically x square plus 8, and this 6 modulus x is this red line, and we can see that it intersecting at 4 points. So all solutions are intersecting points are solution. So this is here we have this is all solutions. For detailed learning, each individual may contact me for explanation. So this is question number 5, challenging question. X plus 1 modulus plus modulus 2x minus 3 is equal to 8, and we actually reshaped this. We shifted x plus 1 on the other side. So rearrangement, we have 2x minus 3 is equal to 8 minus x plus 1. So we have this equation 1, and for positive value, for if we open this in the positive, so we have this. Within negative, this becomes minus 8 minus x. So this is positive and this is negative. So it can be opened with a positive and with a negative. So with negative this becomes, so this one equation and this is second equation, and by solving this equation 1, so we solve this equation 1 first. From this equation 1 we split it into 2 parts by rearranging and then split. We have obtained these 2 solutions. Similarly, from equation 2, this equation, we have other 2 solutions. From equation 2 we have this, and we are rearranged and then form this shape and then split again, and from this split we have this. We have obtained this solution, and with that we have 4 solutions, and we placed this, we checked minus 4. We see that this is false, this is false, this is true. So x is equal to 10 upon 3 is the true solution, and x is equal to minus 2 is the true solution. So we have 4 solutions, obtained 4 solutions, but only 2 satisfies. So we have this minus 2 and 10 upon 3. So this is the solution, actual solution, and it can be seen on the graph. So this one is a solution and this is a solution, and the rest are not solution. So this curve and this curve. This is question number 5. So this question number 5. This is. So on graphical plotting, so this curve is this, and this is the mirror image. Similarly, this curve, basically this one, 2x minus 3, and this is the mirror image. On this point, we have, if we assume it is a normal, then it's the same reflection. So it is intersecting at these 2 points. This is giving the solution. So this is the solution, and during our class session we will discuss in more details. This is very, very important. How we draw this graph, we can easily see that we draw this 8x minus 1, which is this graph, and from that we have this reflection, and 2x minus 3 is this graph. This is 2x minus 3 from here to here, and this will extend the downside, but due to the modulus value it will go up. So this is question 5, challenging problem. Now move to question number 6, and similarly the other parts. So this is exercise 5.1. In the next section we will discuss 5.2.